Really great question on geometric progressions here. So we're told the sum to infinity of a geometric progression is 6. We might straight away just write down a over 1 minus r equals 6. That's what I did. But don't forget that there's actually the sum of a plus ar, and this is normal notation, plus ar squared from then onwards. But we're then told that the sum to infinity of the squares of each term is 12. So let's just check that out. It would be a squared plus a squared r squared plus a squared r to the 4, and so on. And actually, this is still a geometric progression. We're just times in now through by r squared. That's the common ratio, and the first term is a squared. Okay, hopefully I've convinced you of that. So it's actually going to be a squared over 1 minus r squared that's equal to 12. And what we're actually trying to find is the sum to infinity of the cubes. So that would be a cubed plus a cubed r cubed plus a cubed r to the 6. And guess what? This is also a geometric progression, which is now times in by r cubed each time. So what we want to find is a cubed over 1 minus r cubed. We've got these two equations to deal with. So I'm going to times through. A is going to equal 6 minus 6r. And actually, I'm going to backtrack slightly. So a squared over 1 minus r squared is in fact a over 1 minus r times a over 1 plus r. This is a difference of two squares. I think this is a better approach towards it. Because what I can do now is replace this by 6. So actually a over 1 plus r is going to equal 2. Okay, right, I will go back to what I was doing now, but now I've got this equation and this equation, no squares anymore. So a is going to equal 6 minus 6r, and a is going to equal 2 plus 2r. And I can combine these together because these two must be the same. So 6 minus 6r is equal to 2 plus 2r, and that means 8r is equal to 4, so r is equal to a half. And I can just sub that back in to either one. A is going to be 6 minus 3, a is 3. Okay, we found those two values, so we're basically there, because a cubed divided by 1 minus r cubed is therefore going to equal, well, it's 3 to the 3, so 27, 3 times 3 times 3, over 1 minus a half to the power of 3, that's 1 over 8. That becomes 27 divided by 7 over 8, which is the same as 27 times 8 over 7. That ends up being 160 plus 56, that's 216 over 7. So our answer is D. Brilliant question.